Our first type of word problem are the rate, time, and distance problems. And about every algebra book out there always gives you this little formula. D equals to RT. And they tell you that distance equals rate times time. Now, what in the world is rate? What does that mean? And where did this come from? Did some committee set this up? Well, the word rate really is short for rate of speed. I prefer to write speed. And because to me that's a little plainer English. You know, when you drive down the road and you look at your odometer, your passenger asks, well, how fast are you going? Well, I'm going at a rate of 60. My rate is 60. No, you would say my speed is 60 miles per hour. But you don't say my rate is 60 miles per hour, you say my speed is. So, but this, where does it come from? This comes from how we define speed. And so, let's look at that. How does one define speed? Now, I'll give you something kind of familiar. If you were able to drive, let's see, 180 miles in 3 hours, how fast were you going on average? 180 miles in 3 hours, and I know you can do this, would be 60 miles per hour. So we divide, don't we? We take the miles and divide it by hours. And that's what's meant by miles per hour. That little Latin word per means to divide by. Miles divided by hour. Literally, it is. The units are divided here. And if I were to walk across my little spare bedroom here, suppose I could walk 12 feet in 3 seconds. Okay, so this would be what? This would be 4 feet per second. 4 feet per second. Now, what do these have in common? The numerator is a distance, and the denominator is a time. And all measurements of speed have that in common. And so speed, ordinary speed, is a distance measurement divided by a time measurement. So that is how we define it. That's by definition. All right, now, incidentally, there's a more sophisticated word called velocity. And velocity and speed are the same when you're moving in one dimension. But I don't use velocity normally because when you're moving in more than one dimension, 2 or 3 dimensions, velocity also takes on direction. So velocity is speed and direction, whereas speed is just plain old speed. So I like to use the word speed, and I don't know anybody who uses the word rate in common everyday English. So, all right, now normally what we do is we reorganize this equation. So if I were to multiply through by the word time, then on the left side I get speed times time. I'll write that out. Speed, time, multiply together. And on the right side, the time units cancel. And so units are algebraic entities in themselves. They work just like numbers. And a numerator unit will cancel a like denominator unit. So here time cancels on the right hand side, and I get distance. So that's the origin of our distance equals rate of speed times time equation. That's where it comes from. It's a relationship between those 3 quantities. Now, when we're working these types of problems, there always seems to be 2 trips. I suppose there could be more, but in order to solve, we need, normally, to make it interesting as an algebra problem, we usually have 2 trips going on. For example, maybe the person in the problem travels from A to B and then travels back again. Or maybe 2 people are traveling toward each other. There's a lot of varieties there. And but normally there's 2 trips going on in these problems that we'll see. And what you're going to see me do is use this relationship on each trip. And because you can't get away from this relationship. When you have distance and there's a speed or a time involved, there's your equation. It's going to be there. And so we have to use this relationship in solving these kinds of problems. No way around it. That means for each trip has a defined equation associated with it. And then our other challenge is to take those two trips and somehow put them together and into an equation that we can solve for. So there's our challenge for that. But I wanted you to see what's going on with this and get a little deeper insight as to this type of problem beyond just those book formulas.